Okay, so next topic that we are going to talk about is calorimetry. Calorimetry is very simple actually. What is the meaning of calorie? Calorie is the unit of energy, right? Unit of heat energy. Calorimetry. The metric means is a measure. So we are going to measure how much heat a body, like for example in a heat transfer process, that is you are mixing every day we have that experience, we might have that experience all the days, alright. For example, you have a cup of milk and you have a cup of water, and the water is at high temperature and milk is at low temperature. You will mix them. So you know that at least in your mind it is there, the temperature of the mix will be the temperature between the water, initial temperature of water and the milk. Would you agree with me? Alright. So for example, if it is 10 degrees Celsius is 30 degrees Celsius is water and 100 degrees Celsius is milk. Okay. Then if you mix them, it will be somehow in between 30 and 100. Okay. It will not be more than 30. It will not be less than 30. It will not be more than 100. It will not be less than 30 as well. So that thing is very clear. Okay. Now, what is calorimetry? Calorimetry is a branch of physics. So where actually is a branch of even thermodynamics as well. That is where we are going to find out how much heat the body gained, how much heat the body lost. Okay, that is the calorimetry. And one important thing you have to keep in your mind. Look at this. This is a well-defined setup. And it's a branch, so that is why we have everything related to that. So this entire setup is known as calorimeter. Calorimeter. So here we are going to discuss this one. So what is the base of calorimetry, or what is the ideal principle of calorimetry? For example, what is the base principle of thermometer? That is, when the temperature increases, the property, either the dimension of the material or dimension of the gas or the substance will increase. Okay, by using that theory only, we are the entire branch of thermometry works. That is the base principle. Okay, similarly, what is the base principle of calorimetry? When you mix two substances, so the heat gained by one body is equal to the heat lost by the other body. Heat gained by the one body is equal to heat lost by the other body. That is very, very, very logical, right? So if you mix the water and milk, how much heat the water gained, that much heat will be the milk lost. Why? Conservation of energy. Because how much energy lost, how much energy gained, that should be equal. Other energy, where should it go? Wouldn't go anywhere, right? Because conservation of energy. So now, look at this. This is the calorimeter setup. It's very important. So look at this. This is an approximate diagram. My diagram is not very good. Maybe you can draw a better diagram than me. Alright. So you can refer the textbook. That diagram you can copy. That's a very beautiful diagram. It's given. No need to give much color and all like that. Shades are done. Okay. But my calorimeter is not that bad, by the way. So it's good. Everything I have marked. So my thermometer is pretty nice. This one is thermometer. And my stirrer. Look at this. My stirrer is like an ultra modern stirrer. This is a stirrer. And then don't mind about the sand. Okay, don't mind about this one. Keep it there. So without this we just consider. And this is an insulating wood. Why? Because heat should not go outside. And also here we keep a vacuum. Here we air insulation we give. Okay, why? Because heat should not transfer to the atmosphere. We want to make the heat should contain in that calorimeter only. And then we have calorimeter cup. This is a calorimeter. Okay. In that cup, we make setup, like we make some water. We get some water in that, and then a thermometer is placed. Thermometer will measure the temperature of the heat. temperature of the water. And then what is the stirrer? Stirrer we use to do this. Okay, to mix the water and the substance properly. So then heat will transfer to all over the water very constantly or very uniformly. It will transfer. That is why we use stirrer. And we can write all these things. And calorimetric cup is the major part of this one. And that's it. Okay. So what is our major theory? Heat gained by one thing. Look at this here. The sample which we have taken. This is the sample. It is at high temperature. It is at high temperature. Okay. The sample which we have taken, which is at high temperature, we mix it with this water. So what will happen? The heat lost by the sample equal to heat gained by the water. Very simple. Heat gained is equal to heat lost. Who gained heat here? Who gained heat energy here? None other than water. Who lost heat here? This sample. Alright. So T1 is equal to, what is T1? So now we are going to get the equation of the final temperature. So look at this. Let's T1 is the temperature of the sample. T2 is the temperature of water. Okay, so water. Maybe it's at room temperature, maybe 30 degrees Celsius, 30, whatever. So TF is the final temperature. After mixing, we stir very effectively, and the constant temperature is spread around. All the heat is uniformly distributed, and then we measure the final temperature by using our thermometer. Alright. So then our equation, heat gained is equal to heat lost. Look at this. How much is heat gained? How much is heat gained? Let's say who gained the heat? Water. Let's say the mass of water is m1. Okay, sorry. Let's say m2. And because it's given here. Specific heat capacity is s2. Then its heat gained will be m2s2 Tf minus T2. What is Tf minus T2? Tf is at the high temperature. For example, initially at the 30 degrees Celsius water suppose it became 50 degrees Celsius. So what is the change in temperature? Tf minus T2. That is, tell me, that is 50 minus 30. That is equal to 20. Alright. So next is Q loss. How much is the lost temperature? That is temperature lost by this body. That is mass is m1, specific capacity is s1, not s2, s1. Okay. So m1 s1 into Tf minus T1. So that is the other thing. Look at this. So you will have a doubt. Sir, T1 was at high temperature. Tf was at low temperature. Why did you write Tf minus T1? You can write T1 minus Tf also. Then it will come as negative. You got my point? Then it will come as negative. So that is why I have given negative sign here. Okay, one is gaining and one is losing. So that is why the negative sign. Alright. So now both are equate both of them. Equate both of them minus or you can give Tf minus T1 or minus Tf minus T1. That is both are fine. So expand this, take this term to the side. So Tf terms take one side and other terms T1 T2 terms let it go the other side. And by the way, let me ask you a question. What is the heat energy equation? You know that, right? Heat is equal to Q is equal to ms delta T. This is the heat energy equation. You have to have a very good idea about this. Okay, Q, the heat energy is equal to the heat energy gained by a body or lost by a body is equal to ms delta T. What is m? M is mass. M is mass. Okay, what is this? Specific heat capacity. Specific heat capacity. Okay, if you don't know, please note down specific heat capacity. What is specific heat capacity? It is the amount of heat energy required to rise the temperature of a body by 1 degree Celsius of 1 kilogram volt. Alright. So what is delta T? It is the change in temperature. Change in temperature. If delta T is positive, then final minus initial would be it is gain. If delta T is negative, lost. Okay, that is it. ms delta T. Always you keep in your mind. This is actually this topic. It comes under specific heat capacity, molar specific heat capacity, but we don't have that topic in the syllabus. But keep in your mind. This is very important. We need this. Alright. So then you rearrange it. Then take TF outside, then M2S2 plus M1S1 is equal to M2S2 T2 plus M1S1 T1. So what is T final? M1S1 T1 plus M2S2 T2 divided by M1S1 plus M2S2. So this topic, you can expect the complete derivation or the complete formula based question, that is to derive or reduce the question, or other chances you can expect a problem from this. Alright, so let's solve a problem, then you will get more idea. So I'm going to do this. Okay, example number 8.7. Example 8.7. All of you check. A 5 liter of water, so 5 liter of water is given at 50 degrees Celsius, okay, and 4 liter of other water is given, that is at 30 degrees Celsius. The temperature has a difference, right? What will be the final temperature of water? First question. Take the specific capacity of water as 4184. 4184. Specific capacity of water is 4184. Joule per kilogram per Kelvin. Actually, we take this value as 4200 in other problems. Okay, joule per kilogram per Kelvin. Okay. So always remember, this is, we take it as 4184 is the absolute value. So 4186 and 4186 is the correct value. So 4200 is the 4200. For the sake of problem solving, we use this value. How would you do this? Here only one point you have to remember. I am not going to solve this problem. You have to solve this problem. So what I will do is, I will just give you the idea to solve the problem. Okay, how to solve this problem? That idea is here, instead of that how much is heat is equal to ms delta T. Delta T you will get it from here. Okay. Or T final you want to find out. T final you can substitute in that equation. M1 S1 T1, M2 S2 T2, M1 S1 M2 S2. Actually, yeah, do we need a specific capacity here? No. Why? Both are water. Both the things we have, both the substances we have, both are water. Then S1 S2 will be same. So S1 S2 you can take outside. SS will get cancel each other in this problem. Okay. So another one. Mass is not given directly, but they have given the volume, and also they have given it is water. So what is the mass of water? Mass will be equal to volume into density. What is the density of water? That is constant. Okay, so this equation will become M1, mass of first one is equal to V1 into D. What is M2? M2 is equal to V2 into D. Okay, so you can substitute here, that one, here also. So M1, M2, so D also will get cancel each other. T1, T2, substitute the values, you will get it. So this is I will solve it. Okay, no problem. T final is equal to, numerical at least you do. So 5 liter, 5 into 50 plus 4 into 30 divided by 3 plus, 5 plus 4. 5 plus 4, 9. So this is the value, this much degrees Celsius. Okay, so all of you do it. It's very easy question. Then we will see next topic in next video. Okay, thank you.